Alright, in this video, let's take a look at a sine wave and two properties of the sine wave, which are frequency and the period. Alright, so first, let's take a look at the difference between alternating versus direct current. It says direct currents are currents which, even though their magnitude might vary, essentially flow only in one direction. In other words, direct currents are unidirectional. Alternating currents, on the other hand, are bidirectional and continuously reverse their direction of flow. The polarity of the EMF, which produces an alternating current, must frequently also be changing from positive to negative, and vice versa. So what it's saying is basically, let's say that you have a power source, a load. Let's say that this is a direct current, DC, voltage supplied. Alright, so in direct current you have one fixed polarity. This is positive, this is negative, and current is flowing from positive to negative. It doesn't change, okay? In alternating current, let's say now that this is alternating current voltage source. In alternating current, the polarity is always fluctuating. During the positive cycle, let's say that this is a signal, this is a AC signal here. During the positive cycle, this is the polarity, so current is going to flow in this direction. But during the negative cycle, the polarity reverses. So now this side here becomes a positive and this side here becomes a negative. So now current is flowing in the other direction. Current is always flowing from positive to negative, okay? So that is basically what they're saying here in this paragraph. Let's continue. It says alternating current produces alternating potential differences of voltage in the circuit in which they flow. Furthermore, in some circuits, alternating voltages might be superimposed on direct voltages. The resulting voltage might be unipolar, positive, always, i.e. positive, or always negative. They're talking about this circuit here. They're talking about this signal here. Notice that even though it is an AC signal, it is always positive because it is superimposed on a DC voltage. Okay, this is what is called biasing the signal. We haven't arrived to this concept yet, but that's what they're referring here in this paragraph. All right, so let's continue reading. It says waveforms and signals. A graph showing the variation of voltage or current present in a circuit is known as a waveform. There are many common types of waveform encountered in electronic circuits, including sine or sinusoidal wave, square, triangle, ramp, sawtooth, which might be either positive or negative. Let me scroll down here. It says complex waveform like speech and music usually comprise many components in different frequencies. Pulse waveforms are often categorized as either positive or non-repetitive. Repeats regularly, while the latter comprises pulses which constitute a unique event. It says a signal can be conveyed using one or more of the properties of a waveform and sent using wires, cables, optical and radio links. Signals can also be processed in various ways using amplifiers, modulators, filters, etc. Signals are also classified as either analog, continuously variable, or digital based on a discrete state. Alright, so basically they're talking about the different kinds of signals in electronics. These are some of the examples. We have a square wave, which is a constant repetitive pulse. We have a sine wave, which is a sinusoidal wave, a triangle, a ramp, a pulse, and down here a complex signal. This could be an audio signal, a video signal. So let's take a look at the first property of a waveform, which is frequency. It says the frequency of a repetitive waveform is the number of cycles of the waveform which occur in one unit time. Frequency is expressed in hertz, Hz, and the frequency of 1 hertz is equivalent to 1 cycle per second. Hence, if a voltage has a frequency of 400 hertz, 400 cycles of it will occur in every second. Okay, so now this says the equation for the voltage shown in figure 4.1 at a time t is, I don't know why they shift from frequency to this formula here. And this is for calculating instantaneous voltage. For example, the voltage at a specific point on a sine wave. But let's continue. Alright, so that was the first property of a sine wave. The second property that I wanted to cover is the period or periodic time. It says the periodic time or period of a waveform is the time taken for one complex cycle of the wave. The relationship between periodic time and frequency is thus, so this is the frequency, this is the formula for calculating the period or the frequency, which is frequency equals the inverse of the period, or the period equals the inverse of the frequency. And it says that a period is the time that it takes for the signal to complete one cycle. So this is one full cycle here, from this point until this other point. Okay, so let's go ahead and do a couple of exercises. The first one says a sine wave has a frequency of 250 hertz and an amplitude of 50 volts. Determine the periodic time. So the formula is the period t is equals to the inverse of the frequency. So this should be equals to 1 over 250 hertz, and let me pull the calculator. I don't need scientific more for this. So the 1 over 250 equals to, it says undefined results, 1 over 250. Oh, okay, here we go. 1 over 250 . That is 1 over 250. Okay. And that is equals to 0.004 seconds or 4 milliseconds. All right, so that is the periodic time for that sine wave. The other one says determine the frequency values of each of the waveforms shown in this figure. So we only have one sine wave here, and so the frequency, we don't know the frequency, but we can calculate the period. So we can calculate the period by taking a look at when if a full cycle is completed. It is completed right about this point here. So I would say somewhere around 17, 18 milliseconds. So my period is 18 milliseconds. And I need to calculate the frequency. So frequency is 1 over the period. One over 0.018, and that is roughly 55.5 hertz. All right, so that is the video that I wanted to cover today. Thanks for watching.